In solvent-based automotive coatings, the interaction between resin and solvent is a fundamental determinant of film formation, appearance, and long-term performance. Far from being passive carriers, solvents actively govern resin solubility, wet film flow, leveling, and defect risk, creating a dynamic relationship that must be understood at both the formulation and process levels. At the formulation level, resin chemistry dictates compatibility with solvents. Polymers such as acrylics, polyurethanes, and polyesters require solvents of specific polarity, hydrogen bonding capability, and solubility parameters to achieve true molecular dissolution. Correct solvent resin matching ensures homogeneous viscosity, consistent wet film spreading, and continuous film formation. Poor compatibility may result in phase separation, viscosity drift, or surface defects such as cratering, fisheyes, or flocculation. Evaporation kinetics further modulate this interaction. Fast evaporating solvents reduce viscosity quickly, allowing atomization and initial film setting, while slower solvents maintain mobility for flow and leveling. The controlled sequence of solvent loss influences rheology evolution, surface tension gradients, and resin entanglement. In metallic and effect coatings, this determines flake orientation, gloss, and optical uniformity. The cause-effect relationship between resin-solvent compatibility, evaporation, and rheology is direct. A mismatch in solubility parameters can lead to early skin formation or uneven flow. Incorrect solvent ratios may produce gradients in viscosity across the wet film, resulting in orange peel, sag, mottling, or solvent popping. Conversely, optimized resin-solvent systems deliver smooth, continuous films with uniform appearance and minimal defect sensitivity. It is important to recognize differences between laboratory and production behavior. Small lab panels or flat substrates provide uniform drying and heat transfer, whereas full vehicle bodies introduce complex geometry, variable airflow, and thermal mass. These differences affect solvent evaporation rates, local viscosity, and film formation, often amplifying defects that were not observed in lab trials. Understanding these interactions allows RD&I engineers to predict and mitigate scale-up challenges, ensuring successful production outcomes. In summary, resin-solvent interactions are the foundation of flow, leveling, film continuity, and defect control in automotive coatings. Solvent selection, resin compatibility, evaporation kinetics, and rheology evolution must be carefully balanced to translate lab formulation into robust, defect-free production performance. If you have unresolved formulation questions, layer interaction concerns, or production translation challenges, submit them in the comments for discussion in future episodes.